Charles's law deals with the relationship between volume and temperature. And what we find is volume is directly related to temperature. So you get an equation of V1 over T1 equals V2 over T2. Now, if volume is directly related to temperature, that means as volume goes up, temperature has to go up. Or if temperature goes down, volume has to go down. And this is all with the assumption that pressure is constant. So pressure is constant. So let's take a look at a scenario here. Let's say I have 3 molecules that are all flying around here in this container. Now, if I slow down my molecules, so I take my molecules from this scenario, I slow them down, which you can see by the little speed lines, they're slowing down. I would have to decrease my volume, as you can see with the smaller box, to make sure my pressure is consistent. So my pressure is defined by how many times or how frequent a molecule hits off the wall of the container. So if I slow my particles down, that means I need a smaller container so that the frequency that each molecule hits the wall remains the same. So here my temperature is going down, my volume is going down, and my pressure is remaining constant. So let's take a look at a problem. So a sample of neon gas occupies a volume of 752 milliliters at 25 degrees Celsius. What volume will the gas occupy at 50 degrees Celsius if the pressure remains constant? So I always recommend start out the problem by writing out your variables. So you have V1, T1, V2, and T2. Your first volume is 752 milliliters. Your first temperature is 25 degrees Celsius. Your final temperature is 50 degrees Celsius. And we are trying to find your final volume. Now, first thing you have to remember is whenever you're dealing with gas laws, you always have to be in Kelvin for your temperature units. So I'm going to convert my degrees Celsius to Kelvin by adding 273 to both my temperatures. My T1 is going to be equal to 298 Kelvin. My T2 is going to be equal to 323 Kelvin. Now my next step is to plug in to my equation. If you recall, V1 over T1 equals V2 over T2 is my equation for Charles's law. So now I'm just going to plug in my variables. Volume 1 is 752 milliliters divided by T1, which is 298 Kelvin, and that is equal to V2 divided by T2, which is 323 Kelvin. I'm going to multiply both sides by 323 Kelvin so I can get my V2 by itself. Notice that on my one side, my Kelvin temperatures, my Kelvin units cancel out and leave me with the units of milliliters. When I multiply 323 by 752 and divide by 298, I end up getting V2 equaling 850 15 milliliters.